In the last video, we covered the aiming and the model setup of this little turret. This video, we'll cover the shooting and the AI. So we leave the target area. It does this little idle animation. We go back in. It acquires us and it shoots us. And we'll also be covering how if you get like beneath it or something, it won't actually shoot you. So I hope you're excited for that. This video is a little bit long because it's a lot of tuning required, just like the last video, but just in a different sense. So a lot of the parts can be skipped if you tune it quickly, or a lot of it can be like gone fast through. Yes, English. You can go through it fast. But I hope you enjoy. Like and subscribe if you do. Last video of the series. Let's go. And let's jump right into it. So last video we covered the turret part of the AI laser turret. Now we need to get the AI and the laser working. So what does that necessarily entail? So my vision for this turret is that it'll have like a radius around it, like a spherical radius that if any humanoid, so whether they be a player, NPC, whatever, enters it, they'll get zapped, they'll take damage. And once they leave, the AI turret will look at something else or whatever. And it'll have a nice little idle animation too, like people know that it's an active live turret, which should be pretty cool. So let's get started. So the first step is going to be the actual detection. So I'm going to make some room down here because we don't this part, the hinge stuff is going to stay. It's just going to be towards the very bottom. Now we're going to make our main kind of like routing statement for this thing. So we're going to say we're first going to define a variable, call this local target. And we're going to initially set it to nil because this is going to be set to the character that we're targeting, the character that we want to shoot. So if there isn't a target, so if not target, then we need to find one, and then else we're going to like do something else. And we'll handle this else block a little bit later. But for now, let's work on target acquisition, target detection. And the way we're going to do that is using an overlap query in Roblox. So what does that look like? Let's say local parts equals workspace, get part bounds in radius, and then we're going to go to the ref.position where we want to start, and we need a radius, which I'm actually going to go to. I don't know why my properties window keeps on going away. I'm going to actually go to my AI laser turret and create a new attribute and call this detection radius. And I'm going to set this to something like 30 studs. And up at the top, we're going to make a new constant and call this radius in all caps because I like to put my constants in all caps. Doesn't matter, it's up to you, but just personal preference. I'm gonna say turret get attribute detection radius. There we go. So this is gonna be our radius. So in our get parts bounds and radius, send in our radius. There we go. And then we also need to send in an overlap params instance. So I'm gonna create that up at the very top. Say local overlap params equals overlap params dot new. I'm gonna say overlap params. Oh, shoot. Overlap params lowercase dot filter type equals enum dot raycast filter type dot exclude. Then we're going to set the overlap params dot filter descendants instances equal to a table with the turret. There we go. Because all we need to do is exclude our model, our turret model. And then we're going to send that in to our get parts bounds and radius. We're going to send in. There we go. So what does this actually do? It does exactly what it says it does. We look at a radius, we get all the parts bounds. So keyword here is bounds. So it won't actually detect like the outline. So if I go back here, see how if I hover over my model, you can see there's like a little blue outline around the actual cylinder part, and there's this larger kind of box around the entire thing. We're looking at the box, and that's good because this doesn't have to be perfectly accurate. We don't want because that requires a lot of performance that we don't want, especially since we're running this every stepped physics frame. We want a kind of a rough query that uses the bounding boxes of all of the parts. And that's good. So now that we have all the parts, we need to run through them. So I'm going to say for underscore because we don't need the index part in parts do. And so what do we want to do? We want to first check if the part is part of a model. So I'm going to say local character is part find first ancestor, which is a model. So if it's a model and we say local humanoid equals character and character find first child, which is a, there we go. So what we're doing here is we check if it's parented to a model in some part of the ancestry, then we check if that model has a humanoid, if the character exists, because and returns the if this is true, it'll return the second value. If this is false, it'll just return false. And so we can check by saying if humanoid, then that means we have a humanoid and we have a character, and that's great. And all we do is set the target equal to the character, and then we break the loop. You really don't have to break the loop. So the difference is if you don't break the loop, if there's multiple players in your thing, the last or in your little radius, the last character will be set to the target. If you don't, if you leave the break here, it's the first character. Again, the order in which they're selected is probably random. I mean, there's probably some logic to it within this function, but I don't really know, and I don't really care. It doesn't really matter. This break just makes it a little bit more performant depending on the situation because you don't want to keep on like looping through all of them. You already found a valid target. So there we go. But if we were to run this, we would run into a couple of issues. That's because this does not take into account the actual, like, position of our player. So, for example, if, actually, you know what we can do? We can show this. So we can say direction. We can just let's actually copy this line. We can say direction equals ref.cframe point to object space, and we can do target get pivot dot position. There we go. So it should point towards our character. Let's just play this, see what happens. So, what to do it down here. Yeah, because this means we have a target. So there we go. So this is just for testing. You don't really have to do this. It's just to do something. So if we go here, you see it points at us, right? But if we go underneath the turret, it still thinks for a target. Like, dude, you can't shoot through there. Like that doesn't make any sense. So we have to fix that. We can't be having that. So what we have to do is we're going to create a function because we're going to use this function multiple times throughout the remainder of this video called is reachable. So local function is reachable, and we're going to send in a subject, the thing that we want to reach. So what's going to happen here is we're going to basically check to see if the subject is within like the depression range of our gun and if it's also in the line of sight. So if it's like because this function here does not take into account walls, we need to do that. So let's do that. So first we're going to say local direction equals subject get pivot because the subject will be a model dot position minus the reference dot position. We're going to say, and now we need to check the angle. So we're going to say if ref dot cframe dot up vector in the angle of that uh, with direction is less than some value that we're going to define in a second, then we're going to return false. So this means it's not reachable. So, I mean, if it's greater than some value. So what this value is we're going to define another attribute, call this depression. It's not like mental health depression. It means like the weight, how far the gun barrel can go down, like depress into the ground. So, so we're gonna set that to I don't know. Actually, we'll leave it 0 for now. But first, we need to get it in our script. We're gonna say local depression, all caps equal script attribute depression. There we go. We have our depression, and we do if it's greater than depression. If the angle is greater than the depressed angle, then we're going to return false. So what is this depressed angle? How will this work? Let's go test it out. Let's go into the field. So what I'm looking at is the angle at which our turret can go down no more. We're gonna sample our pitch angle here. So I changed my model move mode to physical. Physical. So now what I can do is I can move this down and see which angle I want to like stop. So this is about as far as we can go. This is about as far as it can go because this little base part is kind of big. So I'm gonna go into my pitch and see what angle. It says current angle is 32. Now, through my own testing, that's kinda not the angle we want. We want the, actually, let's try it out. Let's see what happens. Um, let's set our depression to, like, 32. So wait, actually, let's see. Let's see where it goes. Let's actually trace the print. So it starts down at 32, and if we move it up, where does it end up? It goes up closer. So down is 32. So if it's well, this is also keep in mind, this is also the turret angle, not necessarily because what we're doing is we're looking at the up value. So it's like so, eventually we might need, like, the complement to or the actually, the supplement. So let's just see what happens. So we set it to 32. Probably need to offset it by, like, 90 degrees or something. So it's still pointing at us. Angle's not really locking in. So let's actually go into the field and just freaking so I'm gonna copy this value and just print it. So we're gonna print the ref dot oh, wait, I'm stupid. One sec. You have to convert this into degrees. So we're gonna map out degree ref dot angle, and then we're also gonna print it out. This is just how you test it. I know it may make the video a little bit longer because I'm not some genius. Just the angle off the head, but this is how you test your own thing too. So here we go. Well, thing is we're not actually using the reachable function. I'm kind of stupid. So let's put this in to if humanoid and is reachable. Then we set the character. So is reachable character. Then we actually set the target thing. So yeah, see, it doesn't detect us, and then once we get into the range, this is like 180. So let's see, what angle do we want? So it's like 118 out. So let's actually, and it gets smaller. Okay, so we want the depression to be like there we go. Because what that means is that as we get closer, we want this value to be greater. So if this value is greater than the depression, which is like 120, then we return false. Otherwise, we return true. So we should lock on once we get around to the side. So whatever, get a little closer at 90. I'm not locked. Let's see what's going on. So, oh, it's because we're not returning. There we go. So as a test, return true, and is reachable. We make it past a little. Yep, there we go. So we lock on. Obviously, since we have no is reachable check later, it stays locked on. But notice how it doesn't lock on until we get into the range. But along with that, we need to check line of sight. So I'm going to delete this print statement. Sorry for a little like rough around the edges, kind of debugging, but this kind of shows you how you would do this yourself because your gun's going to be different than mine. You need to figure out your depression. Just remember, depression. I would just print out the angle. Don't even use the hinge. That was kind of stupid. I don't know, but don't use the hinge. Just go find the depression yourself using just printing out the degrees. And remember, angle returns radians, so you need to convert that to degrees. But after you've done that, it's time to get the cast for the line of sight. We're going to say cast equals workspace raycast. Then we're going to do ref.position over to the direction.unit times the radius because we shouldn't cast farther out than the radius. And we're also going to send in the cast params that we haven't created yet. So we're going to create some cast params by copying our overlap params because it's literally the exact same except for cast params. And just change it to raycast params.new. And we're going to replace all the overlap params with that. And it's the exact same. So we can just say cast params for our cast. And then we're going to say return cast and cast.instance is descendant of subject. So what we're doing here is we're saying if the cast exists, so if we hit them, if we're within the line of sight and the thing that we hit is actually part of the subject, that means we're good to go. Like the target is reachable. We can shoot them. So we're to play this. we should get more or less the same result, just different kind of form of it. Yeah, so it points at us, right? But right now it still says locked on after we leave like the line of sight. So we also need to set that. So what we're gonna do is we're gonna say, and then after the if not target, like in the other block, we're gonna say else if is reachable target. So each frame we're gonna check if the target's still reachable, and then we're gonna do stuff. And then otherwise, and then otherwise, so at the very end of this chain, so it's gonna be three if else chain, we're gonna put target equals nil. So what's gonna happen is like if we don't have a target, we're gonna try to find a target. If we do have a target and it's reachable, we're gonna shoot them, and this is where the shoot block will be. Otherwise, if we don't have a target, or if we do have a target and it's not reachable, we're gonna get rid of it because like we can't shoot it. So for testing, I'm gonna set direction equal to some like vector3 dot x-axis, so just some random value, and then we're going to run this. So you can see it points wherever, and so now we're just chilling. We go into hiding. We go into hiding, and it just kind of points. It points out to nowhere, and then move back in. Points at us. We move out. It goes back to position. Then points at us. We go into hiding. It goes back. Boom. So that's exactly what we want. Now we will be later adding an idle animation to this. Actually, let's do it now. Pretty simple. So idle animation, what the heck does that mean? Well, I found a really simple way to do it. It's kind of cheaty, but it's not really cheaty, but it's just kind of cool. We're going to say local RNG equals random.new. And then down here in this block, right above the else if, inside of the if not target, we're going to say if RNG next number, so this returns a number between 0 and 1, is less than 0.005, some small number like that. We're going to say direction equals RNG dot next unit vector. So what this will do is the random like number generator library in Roblox actually pretty useful because we get the next number, we see if it's like so every so often, if this is actually less than this value, we're gonna move the target direction to some random number. So this will basically look like it just looks kind of random places over time. So we'll see how this works. So notice how it's pointing there, now it's pointing there, pointing there. And the time between the points is different, so it just looks kind of like it's panning around, which is kind of sick. And then we go in and it's boom, locked on. Hide if we hide away. It just goes points at different. Yeah, there you go. That's cool. So we have our randomness covered, and now we actually have to get to the shooty bit. Let's do some shooting. This is the fun part. It's actually the last part of this tutorial as well. Kind of sad. We're almost done. Okay, well, let's go. So in here, we need to like do stuff. So we're gonna say local cast equals workspace.raycast. And where are you going to raycast from? This is actually a question, big question, because we could do it from the ref, but honestly, to make it as most accurate as possible, we should do it from the very tip of the gun. So what I'm going to do is I'm going to go to my tip of my gun. So we're going to use like this part here, and then we're going to duplicate it. Why did it do? We're going to change it, move mode to geometric. So we're going to use alt click, select this part, duplicate it, and we're going to call this part the tip part. And then we're going to make it a ball just for testing purposes. We're going to move it out a little bit. There. Good. Make it semi-transparent. And then we're going to, for the orientation indicator, I'm going to move it so, what? The front is facing down. So the front is facing forward like that with the up facing up, just because we're going to shoot it out like that. And so we need to make sure the front is facing the front of the gun. And then we're going to verify the welds are all set. The welds look pretty set. Good stuff. We're gonna move the tip. Actually, we can leave it in the housing. And I'm actually gonna make it transparent now that we have it done. Slide off. We don't really need it. Make sure anchor is off because it will be moving with the gun. We want that. So now we're gonna go hit that tip. Say local tip equals turret housing dot tip. And then what we want to do is we want to raycast from the tip dot position to the tip dot cframe dot look vector times some value. I'm going to say 100, and we're not gonna put in our cast params because if this laser beam collides with anything, even if it's a turret, we need to stop it because we can't be having that. Like it has to just keep on shooting, or it can't just shoot through our own turret. That doesn't make any sense. So if we have the cast and the cast dot instance is descendant of the target. So if we hit something and it's part of the target, we gotta shoot them. So we're gonna say target dot humanoid take damage 10. I'm just gonna say 10 as like a random damage value, but I guess we can go into our thing, change it to into our turret, make an attribute, call this damage, set this to like 10. Also, depression is all caps. Let's go. Depression looks a little more sense. I'm gonna say local damage equals crit attribute damage. And we're gonna say damage all caps, and then we're gonna go down, take damage, the damage amount, specify. There we go. And then we'll visualize it later, but let's just double check this works and shoots us. We're gonna play it. So I thought I only told it to do 10 damage, but let's double check. Let's double check. So damage said, oh wait, look at that. We don't have a debounce. So I have a video on debouncing if you guys want to check it out. But what that means is we don't have a cooldown. So when it sees us, it zaps us like it takes like only 100 frames for us to die. So we need to add a cooldown. So the way we're gonna do that is we're gonna go to the top outside of our stepped loop, and we're gonna say local shot time equals 0. This is gonna be the time in between shots. And so we also need to add a new attribute. I'm going to call this the cooldown. So this is the cooldown between shots, the number attribute, and we're going to set that to 1.5 seconds. I'm going to go to the top. We're going to a local cooldown equals turret. Get attribute cooldown. There you go. And then we need to actually set the cooldown. So underneath our is reachable, we're going to say if ET elapsed time minus shot time is greater than equal to cooldown, then we're gonna do all this junk. And then inside of our inner then, after we verify that we can actually shoot, we're gonna set the shot time equal the elapsed time. So this ET, if you remember, goes into here, and it's the time that has elapsed since like the beginning of the game. So what this basically means is when the elapsed time is like minus shot time, so this like value, so this will keep on going up. This will stay static once that's greater than the cooldown. So once enough time has passed so that the distance between when we shot last and what time it is now is greater than the cooldown, then we can shoot again. Then we reset the shot time so we can't shoot again until after that's done. Let's go try this out. Oh, let's go see what we messed up on. We misspelled turret. That's tragic. There you go. Turret spelled correctly. We're going back in to this AI laser turret. Shoot me. But you can see now my health is going down quite slowly. And ladies and gentlemen, we're almost done. All we got to do is visualize that darn cast. So let's do that. I'm gonna go to part, create cylinder, boom, cylinder. I'm gonna make it pretty. If I remember correctly, I did colored. Gamma colored for my kind of like theme. Make that thing neon. Boom. Neon laser beam. Done. Now we need to we're gonna make it a little thin. We're gonna make this like point. The actual distance doesn't matter. My one's a little too. Make it a nice girthy beam. There you go. So if you remember, if you want to watch my stun gun video for kind of like a similar idea, what we want to do since we're using a cylinder is the cylinder's front face kind of faces the middle of nowhere. So it like faces like that way. We don't really like that. What we're gonna do, because we're gonna use like some C-frame positioning to get it into the right spot. And what we want to do is instead of like manually rotating it, whatever, we're gonna actually edit our pivot because when we actually use the pivot, we want it to be at the very back, like back here, and we want it to be rotated facing not the right way. We want to actually be rotated facing our the front of like the gun. Whatever. So the way I get this to work usually is make sure that your pivot offset orientation, the Y is -90. That's how you usually do it if you move it off to the side. Now, depending on which side, like, you move it, you may have to change this to +90, but every time I've done it's negative. This is again, this is another trial by trial, like, do it mess up and then figure it out. But I move this to the edge just to demonstrate to you because we'll position it, like, using the pivot, but remember, very, very important, move your pivot back to the very center of your part. Make sure this position is set to 0, 0, 0 because you don't want to because we're gonna be offsetting it again. So this is our little thing done, and so so now I'm going to rename this to our beam beam, and I'm actually going to clear it, turn can collide off, turn can query off because we don't want it to be able to be detected by rays, and I'm just gonna move it within my AI laser turret because when you guys copy it, I don't want to have anything be in server storage. But in an actual game, I would totally recommend putting this in server storage. But I can do this because you know, can't really see that. It's kind of lodged in there. So now we can go to our turret script. We can go get our local beam template equals turret dot beam. There we go. Oh wait, the beam is not guaranteed. There we go. It's in the AI laser turret now. So we got the turret dot beam. Boom. And then we want to in our take damage block a little bit below, we're going to say local beam equals beam template clone. And we're going to say beam dot size equals vector3 dot new cast dot distance. So how far it takes for us to hit it. And we're going to just reuse the beam dot size dot y, and then beam dot size dot z because cylinders, the x is like kind of the length. That's what we want to use. And we set the beam dot pivot offset equal to beam dot pivot offset minus vector3 dot x-axis times cast dot distance divided by 2. So what this does is we offset our beam pivot by half the distance because we want it to be at the very edge, like I showed you a couple seconds ago. And we can't really set it to the edge before because we set the size programmatically, so therefore we have to set that position programmatically. But after we do that, now we can just do beam pivot to tip.cframe. And that's the beauty of using pivots is because all we have to do to actually move it is pivot to the actual tip where it is, and it'll be positioned correctly. All we have to do is set the beam.parent equal to the workspace. And then we also want to get rid of it after a certain time. So I'm going to go to the very top, say local debris, close game, get service, debris. And then we're going to we're going to do debris, add item, beam after like 0.5 seconds. So it's going to just clear the item off the workspace after 0.5 seconds. So let's play this thing, see if it works. It does work. That's beautiful. So there you have it. You got your AI laser turret. Look at that thing. So majestic. So you walk towards it. Locks on. Starts zapping you. You run away. And oh no, you're out of range. Oh, go back into hiding, and it goes away. This thing is beautiful. I mean, look at how sick it is. I mean, I absolutely love this. Was such a fun project to do. I hope you guys enjoyed it. It's just really freaking cool. It just zaps you. Kind of sick. And he kills you, and then boom, that's it. But yeah, so I hope you enjoyed this video. I hope you enjoyed the last video too. And if you want any more things using this technology, just let me know because you make a tank turret out of this. You can make a battleship gun out of this using like projectiles and stuff, using fast cast or whatever. You can do stuff like that too. So with that, also one other thing, and I remembered it. Just make sure you get rid of your references to your target part because that's just so I can. Where is the target? Yeah. So we can just get rid of this. We don't need this. Other than that, that's it. So I comment any questions or suggestions down below. Like and subscribe if you enjoyed it. I really enjoyed making this. It's a nice video. But with that, I hope you have a nice day and goodbye.